Real and irrational numbers. Euclid's division algorithm. Divisibility of integers. HCF computation. Fundamental theorem of arithmetic. Prime factorization. Applications of the fundamental theorem. Irrationality proofs. Decimal expansion of rational numbers. Prime factors and composite numbers. Now starting, summary. Introduction to real numbers and irrational numbers. Focus on Euclid's division algorithm and the fundamental theorem of arithmetic. Euclid's division algorithm deals with the divisibility of integers, stating any positive integer a can be divided by another positive integer b, leaving a remainder r smaller than b, used to compute the HCF of two positive integers. The fundamental theorem of arithmetic concerns the multiplication of positive integers, stating every composite number can be expressed as a product of primes in a unique way. Applications of the fundamental theorem of arithmetic. Proving the irrationality of numbers like square root 2, square root 3, and square root 5, and exploring when the decimal expansion of a rational number is terminating or non-terminating repeating based on the prime factorization of the denominator. Any natural number can be written as a product of its prime factors. The fundamental theorem of arithmetic states every composite number can be expressed as a product of primes, and this factorization is unique, apart from the order in which the prime factors occur. The fundamental theorem of arithmetic has many applications, including finding the HCF and LCM of two positive integers using the prime factorization method. Theorem: if p is a prime number, if p divides a squared, then p divides a, where a is a positive integer. Proof that square root 2, square root 3, square root 5 are irrationals. Now starting, key takeaways. Euclid's division algorithm efficiently determines the highest common factor, HCF, of two integers by focusing on divisibility and remainders. The fundamental theorem of arithmetic guarantees a unique prime factorization for every composite number, enabling HCF/LCM calculation. The fundamental theorem of arithmetic can be used to prove the irrationality of numbers like square root 2, square root 3, and square root 5. Prime factorization of a rational number's denominator determines whether its decimal expansion is terminating or repeating. Now starting, memory aids. Even robots understand division algorithm. Which represents, helps remember the core concept of Euclid's division algorithm, that any positive integer, a, can be divided by another positive integer, b. The first letters ERUDA stand for Euclid's remainder unique divisibility algorithm. Prime factorization is unique. Which represents, highlights the key characteristic of the fundamental theorem of arithmetic. The prime factorization of a composite number is unique, except for the order. Really irrational, really real. Which represents, a simple rhyme to associate irrational numbers with the broader set of real numbers, emphasizing that irrational numbers are a subset of real numbers. HCF equals highest common factor, prime factors are key. Which represents, connects the HCF, highest common factor, to the prime factorization method, a key application of the fundamental theorem of arithmetic. This emphasizes that prime factors are essential for finding the HCF. If prime divides square, prime divides root. Which represents, a concise rhyme encapsulating the theorem. If a prime number, p, divides a squared number, a squared, then p also divides a. Visualize square root 2, square root 3, square root 5 climbing out of a square root jail cell, emphasizing their inability to be expressed as simple fractions. Which represents, creates a visual image to remember that square root 2, square root 3, and square root 5 are irrational numbers. The jail cell signifies their imprisonment within the realm of irrationality, unable to escape into the world of rational fractions. Terminating decimals need only 2s and 5s. Which represents, highlights that the prime factorization of the denominator of a rational number determines if its decimal expansion is terminating. Specifically, only factors of 2 and 5 in the denominator result in a terminating decimal. Now starting, fun facts. The concept of zero as a number was developed in India around the 6th century AD. Pythagoras, of Pythagorean theorem fame, believed that all numbers were rational. The symbol for infinity, infinity, was first used by the English mathematician John Wallis in 1655. Prime numbers are used in cryptography to secure online transactions. The largest known prime number has over 24 million digits. Ancient Egyptians primarily used fractions with a numerator of 1. The word algorithm comes from the name of the Persian mathematician Muhammad al-Khwarizmi. Now starting, spotlight on greatness. Spotlight on greatness, Euclid. Euclid's Elements, one of the most influential works in the history of mathematics, was used as a textbook for over 2,000 years. Despite his immense influence, very little is known about Euclid's personal life or even when and where he was born. Euclid likely studied at Plato's Academy in Athens, though this is not definitively proven. The Elements is not a collection of Euclid's original discoveries, but rather a compilation and systematization of existing mathematical knowledge. Many stories, likely apocryphal, surround Euclid, showcasing his dedication to logic and teaching. Euclid's work significantly influenced Islamic mathematics during the Islamic Golden Age. There is debate about whether Euclid was a single individual or a group of mathematicians working under that name. Euclid's approach to geometry, known as Euclidean geometry, assumes a flat space and is still taught in schools today. Euclid did not explore non-Euclidean geometry, which deals with curved spaces and different axioms. Euclid's Elements consists of 13 books covering geometry, number theory, and solid geometry. Now starting, infographic. Real numbers and theorems. Exploration of real, irrational numbers, Euclid's algorithm, and the fundamental theorem of arithmetic. Key concepts for number theory. Euclid's division algorithm. Divides integer a by b, resulting in a remainder r less than b. Used for computing the highest common factor, HCF. Fundamental theorem arithmetic. Every composite number can be uniquely factored into a product of primes. Crucial for number theory. Proving irrationality, square root 2, square root 3, square root 5. Proves numbers such as square root 2, square root 3, and square root 5 are irrational using the fundamental theorem of arithmetic and prime factorization. Decimal expansion analysis. Determines if a rational number's decimal expansion terminates or repeats based on the denominator's prime factorization. Prime divisibility theorem. If prime p divides a squared, then p also divides a, where a is a positive integer. A core number theory concept. Now starting, flashcards. What is the core concept of Euclid's division algorithm? Any positive integer a can be divided by another positive integer b, leaving a remainder r smaller than b. What is the fundamental theorem of arithmetic? Every composite number can be expressed as a product of primes in a unique way. What aspect of numbers does Euclid's division algorithm address? Deals with the divisibility of integers. What aspect of numbers does the fundamental theorem of arithmetic address? Concerns the multiplication of positive integers and their prime factorization. What is a practical application of Euclid's division algorithm? Used to compute the HCF of two positive integers. What is the prime factorization method's utility, as related to the fundamental theorem of arithmetic? A method to find the HCF and LCM of two positive integers using prime factorization. Definition of an irrational number. A number that cannot be expressed as a ratio of two integers. Definition of a composite number. A positive whole number greater than 1 that has more than two factors, i.e., it is not prime. If p is a prime number, what does it imply if p divides a squared? If p divides a squared, then p divides a, where a is a positive integer. What is prime factorization? A method for expressing any natural number as a product of its prime factors. Now starting, missing word. Euclid's division algorithm deals with the dash of integers. Divisibility. Explanation. This highlights the core concept of Euclid's algorithm. The fundamental theorem of arithmetic concerns the dash of positive integers. Multiplication. Explanation focuses on the arithmetic operation at the heart of the theorem. The fundamental theorem of arithmetic states every dash number can be expressed as a product of dash. Composite primes. Explanation tests understanding of composite numbers and prime factorization. Euclid's division algorithm is used to compute the dash of two positive integers. HCF. Explanation highlights a key application of Euclid's algorithm. Any natural number can be written as a product of its dash dash. Prime factors. Explanation reinforces the concept of prime factorization for natural numbers. The fundamental theorem of arithmetic has many applications, including finding the dash and dash of two positive integers. HCF, LCM. Explanation shows practical uses of the fundamental theorem. Applications of the fundamental theorem of arithmetic include proving the dash of numbers like square root 2, square root 3, and square root 5. Irrationality. Explanation connects the theorem to proving irrationality. The fundamental theorem of arithmetic is used to explore when the dash expansion of a dash number is dash. Decimal, rational, terminating. Explanation links the theorem to decimal representation of rationals. Euclid's division algorithm states any positive integer a can be divided by another positive integer b, leaving a dash r smaller than b. Remainder. Explanation focuses on the key result of the division algorithm. The dash of the denominator determines if the decimal expansion of a rational number is terminating or non-terminating repeating. Prime factorization. Explanation emphasizes the role of prime factors in decimal representation. Option A, HCF of positive integers. Option B, LCM of positive integers. Option C, prime factorization of integers. Option D, decimal expansion of rational numbers. Correct. The answer is HCF of positive integers. Explanation Euclid's division algorithm provides a method to determine the highest common factor, HCF, of two positive integers. What does the fundamental theorem of arithmetic state? Option A. Every integer can be expressed as a sum of primes in a unique way. Option B. Every composite number can be expressed as a product of primes in a unique way. Option C. Every rational number can be expressed as a product of primes in a unique way. Option D. Every irrational number can be expressed as a product of primes in a unique way. Correct. The answer is, every composite number can be expressed as a product of primes in a unique way. Explanation The fundamental theorem of arithmetic guarantees a unique prime factorization for every composite number, disregarding the order of factors. If p is a prime number and p divides a squared, where a is a positive integer, what can be concluded? Option A. P divides a squared only if p is a perfect square. Option B. P divides A only if A is a prime number. Option C. If a prime number P divides A squared, then P divides A. Option D. P divides A squared only if A squared is a multiple of P squared. Correct. The answer is, if a prime number P divides A squared, then P divides A. Explanation If a prime number divides the square of an integer, it must also divide the integer itself. The product of the HCF and LCM of two positive integers A and B is equal to Option A. The product of the two numbers. Option B. The sum of the two numbers. Option C. The difference of the two numbers. Option D. The quotient of the two numbers. Correct. The answer is, the product of the two numbers. Explanation The product of the HCF and LCM of two numbers is always equal to the product of the two numbers. The sum of a rational and an irrational number is Option A. Always rational. Option B. Sometimes rational, sometimes irrational. Option C. Always an integer. Option D. Always irrational. Correct. The answer is, always irrational. Explanation The sum of a rational and an irrational number is always irrational. Any natural number can be obtained by Option A, dividing prime numbers. Option B, adding prime numbers. Option C, multiplying prime numbers. Option D, subtracting prime numbers. Correct. The answer is multiplying prime numbers. Explanation: natural numbers can be constructed by multiplying prime numbers. Square root 2 is Option A, rational. Option B, irrational. Option C, integers. Option D, prime. Correct. The answer is irrational. Explanation: numbers such as square root 2 are considered irrational. The prime factorization of a natural number is Option A, unique, except for the order of its factors. Option B, always the same. Option C, unique and ordered. Option D, never unique. Correct. The answer is unique, except for the order of its factors. Explanation: the prime factorization of a natural number is unique, only the order can be different. The quotient of a non-zero rational number and an irrational number is Option A, always rational. Option B, sometimes rational. Option C, always an integer. Option D, irrational. Correct. The answer is irrational. Explanation: the quotient of a non-zero rational and an irrational number is irrational. The HCF and LCM of two positive integers can be found using Option A, long division. Option B, Euclid's division lemma. Option C, prime factorization. Option D, direct multiplication. Correct. The answer is prime factorization. Explanation: HCF and LCM can be conveniently calculated using prime factorization. Now starting, odd one out. Which of the following does not directly relate to theorems about integers? Euclid's division algorithm. Irrationality. Fundamental theorem of arithmetic. The odd one out is irrationality. Because Euclid's division algorithm is about divisibility of integers, while the fundamental theorem deals with the prime factorization of composite numbers. Which of the following is not directly proven to be irrational in the chapter? HCF. Square root 2. Square root 5. The odd one out is HCF. Because square root 2 and square root 5 are proven to be irrational using the fundamental theorem of arithmetic. HCF is found using Euclid's algorithm. Which concept is not directly used to find the HCF and LCM of two integers? HCF. LCM. Divisibility of integers. The odd one out is divisibility of integers. Because HCF and LCM can be calculated using prime factorization. Divisibility is a broader concept related to Euclid's algorithm. Which of the following is not directly related to the fundamental theorem of arithmetic? Prime factors. Irrational numbers. Natural number. The odd one out is irrational numbers. Because natural numbers can be expressed as product of prime factors. Irrational numbers cannot. Which of the following is not directly related to the fundamental theorem of arithmetic? HCF. Prime factorization. Composite number. The odd one out is HCF. Because composite numbers can be uniquely factored into primes. HCF is a result of Euclid's algorithm and factorization. Which of these terms does not directly describe a decimal expansion of rational numbers? Irrational. Terminating. Non-terminating repeating. The odd one out is irrational. Because terminating and non-terminating repeating are types of decimal expansions for rational numbers. Irrational numbers have non-repeating decimals. Which of these is not necessarily irrational? Prime number. Sum of rational and irrational. Quotient of rational and irrational. The odd one out is prime number. Because the other two are properties related to operations between rationals and irrationals. Which of the following is not directly related to prime numbers? P divides A squared implies P divides A. HCF, A, B, LCM, A, B, equals AB. Prime factorization. The odd one out is HCF, A, B, LCM, A, B, equals AB. Because the product of HCF and LCM equals the product of two integers. The others are properties of prime numbers. Which of the following is not an example of an irrational number? HCF. Square root 3. Square root 5. The odd one out is HCF. Because square root 3 and square root 5 are irrational numbers, HCF is the highest common factor. Which of the following is not a type of number? Prime factorization method. Natural number. Composite number. The odd one out is prime factorization method. Because prime factorization method is a technique. Composite and natural. Euclid's division algorithm. Divisibility of integers. Fundamental theorem of arithmetic. Unique prime factorization. Composite number. Product of primes. HCF. Highest common factor. LCM. Least common multiple. Prime factorization. Finding HCF and LCM. Irrational number. Non-terminating, non-repeating. Rational number. Terminating or repeating. Prime number divides A squared. Prime divides A. Rational plus irrational. Irrational. Real number. Deal lumber. Irrational. National. Euclid. Fluid. Division. Incision. Integer. Linger. Prime number. Climb under. Composite. Opposite. Natural. Habitual. Factor. Tractor. HCF. LC.